Hi everyone, welcome to my YouTube channel. Today we would be talking about RAG, which is Retrieval Augmented Generation. In this video we would be talking about how we could basically build a RAG. But before we get into it, let's understand why we basically need RAG. Yeah. If you consider the current LLMs, there are a lot of drawbacks. First being the hallucination. When I say hallucination, what happens, you can try, you can open any of the GPTs that are available, specifically LLM of OpenAI, which is ChatGPT. You just open it and give a prompt saying that, I have a car with that's name of the car is Splendor, and for 1 liter of petrol, it is giving me some 45 kilometers per liter, kilometers per liter. Then what it does is it will hallucinate and it gives you the answer, which is actually ideally not true. There is no fact check here. Yeah. And also the outdated information. This one, last week my friend was calculating his taxes, even when he said calculated for the financial year 26 25 25 26 26 27, the calculations were wrong because it doesn't have the data updated. I think except Grok, there is no other LLM which is updated, but now they have introduced something called web search, which basically acts as RAG itself. Yeah. And also low efficiency in parameterizing the knowledge. When I say parameterizing the knowledge, basically LLM, they are not great at storing massive amounts of data for a specific industry or specific fact, or it doesn't have that capability of basically handle the frequency of changes in the knowledge directly, and it lack of in-depth knowledge in specialized domains, as I said. Yeah? And weak inferential capabilities. This is something where they are not great in having a complex reasoning logic or drawing to the conclusion that go beyond the surface level. For these, you have to completely ground the data and give it to the LLM, any of the LLMs that are available as of now. Now, why we need this RAG and what are the requirements of current applications. Now, for instance, if I'm building an application, my main motto would be grounding its knowledge, grounding its to a domain specific knowledge. For example, if I'm building an app that basically gives me a data on current affairs or a data on geography, so what I have to do is I have to basically fine tune the LLM and bring it to a position where it gets what I'm asking rather hallucinating. And also if I'm building an app, there will be a lot of data that is getting updated very frequently, and explainability of generated content as well. There are no links or logical connection. If we train any model on huge volume of data, where you basically what you do is overfit the data. Yeah. And also cost control, because however prompts you use, it may not work. And privacy of data. For example, if you're dealing with the sensitive data, you cannot train it openly, rather having some contracts where you kick in the anonymization service and get it done. Yeah, these are the actually current trends of any of the applications if you want to build using AI. Now, let's talk about grounding and how it can be achieved. To overcome the issues that we have seen in the last slide, now what are the techniques? For instance, you are using ChatGPT. Now for that ChatGPT, you want to provide the latest information which is happening and you want to ground the context. Then how do you do that? Let me explain. Grounding basically refers to bringing your model in a contextual rich mode, in the sense where you basically give a context to the model and ask it that, whenever you prompt it, you will basically ask saying that this is the way you basically have to give, rather you assuming it. For example, I may tell a model that, model, you are an expert in tax filing and these are the different rules of tax filing. Now I will ask you a few questions. You have to become contextual relevant and answer me. Yeah. Now to do this grounding, there are different methods, where one is fine tuning, another one is prompt engineering, and RAG, retrieval augmented generation. And you do have different techniques called structured data injection, knowledge graphs, and when you have a human in the loop who gives basically these data, then it would work. Now, as I said, why we need grounding? Grounding is majorly to have the contextual relevance to the LLM. Yeah, you are grounding it. When you say you are grounding it, you are giving LLM a narrow direction to think only in this context. Now, why do we need RAG? RAG is one of the popular techniques, as we know, as I showed you just now. Then why do we need it? Now, as of now, as I said, all the GPTs are trained on the data which is passed, and you don't have any grounded information anywhere, right? You don't find it. So the first use case is reducing the hallucination, where you tell the LLM, boss, you don't apply your brain and your creativity, follow the instructions, what is there, what I have grounded, you go through it, and then you apply your language modification skills or summarizing skills or whatsoever. And also what it does is, whenever you do grounding with RAG, whenever you pass some data, it basically keep all the answers relevant and updated. When I say updated, provided that you have to provide the updated information in the document that you are going to give to RAG. And also domain specific knowledge. For instance, if I am CA, what I do is I will train I will create a vector DB with all the relevant articles of basically a chartered accountant curriculum or whatsoever. That's why we basically need RAG. The best answer, single answer, is to ground the information to the knowledge base that you have. Now let's understand what is RAG. RAG basically stands for Retrieval-Augmented Generation. It is one of the techniques that combines two things. One is retrieving, another one is generating. What does it retrieve? It retrieves the data that you have given as an external knowledge source, and the generator, what does it do? It basically acts as, an LLM. It is basically an LLM that uses your information and gives you an answer. As simple as that. Retriever, what it does is it will basically pull the relevant information that you have provided, and generator, it uses the information which you have provided and it works in parallel with the LLM and give you some output. Now let's understand the RAG pipeline. And to make this simpler, I have broken down this one into two steps. One is data indexing, where we talk about how the data is getting indexed, embedded and stored into vector DB, and the other part is how data is retrieved and generated. When we talk about data indexing, here what we are doing is we are converting our documents into vector embeddings. When I say vector embeddings, it is basically a mathematical form of representation of your data. I will tell you simple, a very simple analogy or something, where if you go to a grocery store and ask for an apple, they will give you apple fruit. But if you go to a mobile phone shop and ask an apple, they will give you a mobile phone. So in this data indexing, what we are doing is we are making a vector DB which is contextually rich and which basically understands what type of product you are referring to, or the word that you are referring to as per the context. Now this is the other part which I was talking about, data retrieval and generation. In this, what happens is we basically query to the database and generate contextually relevant responses. Once we have established how RAG pipeline functions, the next step is integrating it with the model here. Now, for instance, you have set up your vector DB and user has done the query. Whenever user does the query, what happens is, first two things will happen in parallel. One query would go to the LLM, the other one, it fetches the data from the vector embeddings and then it will retrieve. From that, it will take top k chunks, basically 4, 5, 6, 7 chunks, and then this query in parallel with the data that is fetched, LLM would process it and give it a response. I hope it is clear. Let me explain it again. So in the data retrieval and generation part, what's happening is, whenever user is querying, whenever there is a query from the user, two things happens. One is vector embeddings, it will get hit. From there what happens is, from the vector DB it will take the data, relevant data. When I say relevant data, what it does is it will search for the relevancy and it will fetch some top 5, 4, 10 chunks, 10 chunks, but basically top 4 gets picked up very well. And then in parallel it will work with the LLM gives priority to this particular data which we have fetched, rather the data that is there or trained on this LLM, and then it will give you the response. This is how data retrieves and then gets generated. Let's understand the basic architecture. As I said, first user would query, retriever kicks in, it retrieves the relevant chunks. From there it works with the LLM, and then finally you will get an answer like as showed it here. Documents first. This is the pre-work. This is something which you already do in the background, where you basically load all your documents and then split them and then prepare a vector DB where you store all your vector embeddings there. And then user, when you had developed your application, user basically queries it. Once the user performs his query or sends his query, retrieve would get the data from the vector embeddings, and then it works in parallel with the LLM, and LLM would give you the output, which is context rich, and where here you are grounding all your information. As simple as that. To implement this RAG, it is very simple. Lot of tutorials are available, and I think from OpenAI or from LangChain itself you have multiple codes, as you can check it in deep learning AI as well. But the best tech stack that we can use for this is, you can use LangChain as a framework, which basically orchestrate your complete application. LLM, you can use any of the open source LLMs that are available. In our example, we will use ChatGPT. We may use GPT 4o, and then for embeddings you can use OpenAI's or Hugging Face. Hugging Face I recommend, and Vector DB, any of these DBs that are available as an open source, you can use it. And UI is very optional. If you are just trying to play in the Jupyter notebook, that is still fine. UI is not required, but with only these we can basically achieve what we want to do. So one simple task what we could do is download all the government schemes that are available till 2025 which are active, and then prepare a chatbot where we basically can ask the LLM or the RAG model that we prepare to tell me how I can get benefited with the government. For instance, I have a persona like farmer, or I have a persona where I am looking for a sponsorship for my product or startup. Now I just go back and train and give the external knowledge source on all MSMEs as SMEs to the vector DB. I basically give all the relevant information, and then I start asking it what is the minimum eligibility, what shall I do, if I want to do the proposal, to whom I should send. So what we have done overall, we have grounded the entire information and made a context rich data which works in parallel with the LLM and gives me the best results. So we will do one practical implementation in our next video. Till then, have a good day. See you soon.